Yes, so welcome back to Luke John Bhakta Singh Imarazu YouTube channel. It is my YouTube channel. So now let us discuss about Millman's theorem. Millman's theorem. Millman's theorem. Yes, this is very it is very easy to understand, and it is very useful to apply for solving any problem, and we can also use this Millman's theorem as the shortcut in the gate examinations while solving the problem with KCL like that. So therefore let us discuss about the Millman's theorem, and after that we will solve some problems also. Yes, what is Millman's theorem? In the sense, when several batteries with their internal resistors or several voltage sources with their internal impedances are connected in parallel across the load resistance, can be replaced by the single voltage source connected in series with the single resistance or single impedance across the load. Yes, it is very similar to the Thevenin's theorem. Yes, how it is in the sense, suppose for example, I have the circuit like this. That is, my circuit contains the battery. This is the battery with the internal resistance. One more battery with internal resistance. Like that, I have so many batteries. Let it be n batteries are there, and these are connected to the load resistance in this fashion, RL. Let it be, this is A and here it is B. Let the first battery voltage is V1 and this is R1, V2, R2, so on, Vn, Rn. This can be replaced by the single voltage source plus minus connected in series with single resistance across the load terminals. It is A, B like this. Let the value of load is RL as it is. And here with the name of Millman's, this voltage is Millman's voltage and this resistance is Millman's resistance. But the Millman has given the formula for that. What is the formula? In the sense, Vm is equal to V1 G1 plus V2 Z2 plus so on plus Vn Gn divided by G1 plus G2 plus G3 so on plus Gn. Now what is this Rm? Rm is equal to 1 by G1 plus G2 plus so on plus Gn. Yeah, it is valid for the DC. If suppose I have the AC network is there, AC source are connected in parallel. Let it be, this is Z1, the internal impedance of the source V1, Z1, next Z2, internal impedance of the source 2, V2, Z2, so on. The nth impedance is Zn, Vn, and here I have this ZL. Yes, the several voltage sources with their internal impedance are connected in parallel across the load impedance ZL. This can be replaced by the single voltage source connected, that is Vm, in series with single impedance across load impedance. The single voltage source is Millman's voltage Vm, single impedance is Zm, and a load is Zl. This is AB. Yes, in the first case, how much current flows through the RL? Let it be IL. Here the value of IL is equal to Vm by Rm plus RL. Yes, and similarly, how much value of IL here? So first, before finding the IL, what is Vm? Vm is equal to V1 Y1 plus V2 Y2 plus so on, Vn Yn divided by Y1 plus Y2 plus so on Yn. Yn, this is Gn. Yn. Now what is this Y? Y is the admittance. Y is inverse of the impedance. And here also similarly, what is G? G is the conductance. G is conductance. Conductance is inverse of the resistance. Conductance is inverse of the resistance. So now you have the values of value of Vn. And similarly, what is Zm? Zm is equal to 1 by Y1 plus Y2 plus so on Yn. So here also, how much current flowing through the load? Zl is equal to Vm by Zm plus Zl. Okay. Now let us solve one problem. Yes, our problem is to verify the Millman's theorem for the network. The network is like this. Verify the Millman's theorem for the network as shown in figure. This is 12 volts. Here let it be the resistance is 3 ohms, and here it is 18 volts. Here the resistance is 6 ohms, and let it be this is 2 ohms. Now we need to find out the current flowing through the 2 ohms by using the Millman's theorem, and also we need to verify this. Okay, first, how you can apply the Millman's theorem in the sense? So first, by using Millman's theorem. By using Millman's theorem. So first of all, we need to identify what is the value of load. So here the load is RL is equal to 2 ohms. Step 1. Next, step 2. What is V1, R1, V2, R2, V3, R3, like this. So here V1 is 12. V2 is 18 volts. And R1 is 3 ohms. R2 is 6 ohms. R1 is 3 ohms and R2 is 6 ohms. Then what is Vm? Third step. So second step itself. Vm is equal to V1 G1 plus V2 Z2 by G1 plus G2. Now what is V1? 12. G1 is 1 by 3 plus V2 is 18 by 6 divided by 1 by 3 plus 1 by 6, because here the value of Z1 is equal to 1 by R1, that will be 1 by 3, and G2 is equal to 1 by R2, this is 1 by 6 ohms. Okay, now we can make the count. 3 ones are 3 fours are 6 ones are 6 threes. So then Vm is equal to 4 plus 3 7 divided by LCM is 6 2 plus 1, or you can also write 7 into 6 by 3. 3 ones are 3 twos, it is 14 ohms. Okay. Now what is third step? The third step is we need to find the value of Rm. Rm is equal to 1 by G1 plus G2. G1 is 1 by 3 plus 1 by 6. So that means here this value is 1 by 3 by 6. 3 ones are 3 twos. Hence Rm is equal to 2 ohms. So we have Rm value. Okay, now let us draw the Millman's equivalent cycle. Millman's equivalent cycle. This is Vm, Rm, RL. So here RL is 2 ohms, and Rm is 2. Yes, both are 2 only. What is IL? IL is equal to Vm by Rm plus RL. Vm by Rm plus RL. So where Vm is, how much value of Vm? 14 volts. 14 divided by 2 plus 2. This IL is equal to 14 by 4. 2 2s are 2 7s. This is 7 by 2 amperes or 3.5 amperes. So this is according to the Millman's theorem. So now, is it right? Do you have the confidence? Whatever I have done here, is it right? Now we need to verify this. Yes. Let us verify this one. The same network I am taking. Let it be this is I1 and here it is I2. This is ground and let it be this is node 1. At node 1, let us apply the KCL. If you apply the KCL at node 1, KCL at node 1, incoming currents are equal to outgoing current. Incoming currents are I1 and I2. Therefore, I1 plus I2 is equal to IL. Now, what is I1? I1 in the sense, let the node voltage is V1. I1 is, so here it is connected like this. This is 12 volts, 3 ohms, node 1, V1. The current flows in this fashion. So hence I1 is equal to 12 minus V1 by 3. Similarly, I2 is this is I2. Node voltage is V2. And here this voltage is ground. That is ground voltage is 0. Here it is 18 volts, 6 ohms. So hence I2 is equal to 18 minus V2 by 6. V2. 18 minus, not V2, this is V1 only. Because the same node, single node is there. V1. Yes, next what is IL? IL is like this. Node voltage is V1, RL, IL flows in this fashion, which is V1 minus 0 by RL, that is V1 by RL, because the voltage at ground is 0. Now we substitute all these things in this equation. So then it is 12 minus V1 by 3 plus 18 minus V1 by 6 is equal to V1 by RL. So in order to find the value of IL, so here you need the value of RL and V1. What is the value of RL? RL is 2 ohms only. So hence IL is equal to V1 by 2. V1 by 2. That means simply if I know the value of V1, then I can able to estimate what is the value of IL. So hence let us we find the value of V1 here. 12 by 3 plus 18 by 6 is equal to V1 by common 1 by 2 plus 1 by 3 plus 1 by 6. Okay. So here let me take 3 ones are 3 fours are 6 ones are 6 threes are. Then it is 4 plus 3 7 is equal to V1. Yes, let it be, this is 6 twos are 12. Then it will be 6 plus 4 threes are 12 plus 2. Yeah, therefore 7 is equal to V1 into 12 by 12. This is 1 ohm. So hence V1 is equal to 7 ohms. V1 is equal to 7. Yes, once I got the value of V1, then I can estimate the value of IL. So hence IL is equal to V1 7 by 2. This is 3.5 amps or 7 by 2 amps. Okay, now you see the same thing is verified. In the case by applying the Millman's theorem, you have 7 by 2 amps, and by applying the KCL directly we have the 7 by 2 amps. So therefore the Millman's theorem is verified. So this is how we can solve the problem. So thank you for watching this video. If you have any doubts, you can mail me at my mail ID ILJ. That is already I have written here. That is ILJ BAKHTSINGH @gmail.com. Thank you for watching this once again.